Hello. Now with all that preparation of absolute value, intervals, set theory, let us proceed towards inequations. Now word inequation is new to you. I'm sure you all have heard word equations. Now I have attached here say prefix in. Whenever we attach prefix in like informal, inappropriate, means what? Inappropriate means the one which is not appropriate. Informal means the one which is not formal. So inequation means the one which is not an equation. Equation has its property. What is it? That equation has always equal to sign. On two sides of equal to sign, there are expressions of x, or maybe on one side expression of x, other side some constant. That is how we have always seen an equation. Now I am talking about inequation here. So what all you are expecting? That instead of equal to sign, there could be some unequal sign. Means it could be less than or it could be greater than sign. So let me define what I have for an inequation. Let x be a given set. And I have say two expressions px and qx with me. Now those px and qx will have some sign between them. So I may have px greater than qx. Now some of you may wonder that is it the only inequation px greater than qx? Can't we have px less than qx? Of course you may have. The question is what you have called as px and what you have named as qx or px is your choice. So some may call px greater than qx and some may read it as qx less than px also. So it's only question of reading, how you read it. So if you wish, I can always say px less than qx is also an inequation. Now, whenever I write an inequation here, say in front of you, you will ask me first question that can we solve inequations also the way we have solved equations? Now, just recall that what we meant by solution of an equation, that we were looking for values of x. If we substitute those values of x in the given equation, two sides were becoming identical. That is what we know about solutions of equation. Now, can we extend same idea for inequation? That may not be the case because their two sides were becoming identical. Here, there is no question of becoming two sides identical. One side would always remain greater and other would always remain less. So, we will have to redefine here solution of inequation. It will not be same as solution of equation. So, we say that all those values of x which make expression px greater than qx, they would be called solutions of inequation. And what would be the solution set? Now, it may not be finite in number, that you will have to remember. In case of equations, number of solutions most of the time were finite in quantity. But here, solutions of inequations are most of the time infinite in number. So, they would always appear in the form of either open interval or closed interval or semi-open, semi-closed type of intervals. So, we will have to collect them and all such values are collected in one set and that set would be called solution set. Now, what type of inequations we are expecting? Is it only the strict inequation of the form px greater than qx? No, not necessarily. It also could be of the form px greater or equal to qx. So, we name them. Px greater than qx would be called strict inequation. Px greater or equal to qx would be called non-strict inequation. Now, after knowing these two, now I am sure you all are prepared to find out the solution. Now, as I have already told that solving inequation is not so simple task. So, we will have to learn certain rules. What we do in case of inequations, solving, that we try to reduce the inequation or the given inequation in a simpler notation. So, that comes under equivalence of inequations. Now, what we will be doing, one inequation after certain operations will be reduced to a simpler inequation whose solution perhaps is easy to understand. So, we make certain transformations on the given inequation and it is reduced to a simpler inequation named as equivalent inequation. So basically, you know what we will do. Given inequation is here, we make certain operations and the final answer would be in terms of perhaps another inequation. For example, if I say x greater than 7, is it not easy to understand? This kind of thing we have already seen when we were writing intervals. So writing solutions for inequation is not at all difficult once you arrive at the simpler equivalent inequation. Now what are the rules? Those rules are actually named here or called here as assertions. Now certain rules will have to be followed. I take first one as px less than qx. If I multiply by minus 1 sign, inequation sign will reverse. That means if previously it was less than, now it becomes greater than. So px less than qx reduces to minus px greater than minus qx. Now what about next one? If I have px greater than 0, means it is positive, qx is also positive. And if I am given px less than qx, then their reciprocals will not have same sign between them. Means if px is less than qx, 1 upon px will become greater than 1 upon qx. So whenever you take reciprocal, make sure inequation sign is reversed. Next could be that I want to add a certain quantity on two sides of given inequation. Means px less than qx is given to me and I want to add rx. Rx may have any sign, positive or negative. You are free to add rx on two sides without changing inequality sign. So this is easiest, that you are allowed to add any quantity on two sides. But don't forget, you have to add on both the sides. You can't add only on one side, of course. Now next is, if I have px, qx, rx, three quantities and I multiply by rx, can I multiply straight away? If rx is positive, then same inequation sign would be retained. Means if px is less than qx, then px into rx is still less than qx into rx. Means multiplying by positive quantity is easy. If you are multiplying by negative quantity, then you have to remember that you have to change the inequation sign. Now another operation what you may think of, that can I square two sides, which is the easiest operation everyone thinks. That if px is greater than 0 and qx is greater than 0, and if you are given px less than qx, then you can square on two sides without changing inequation sign. Means when both sides are positive, you can square. Now this particular rule at times is misunderstood by students. They think that we can square only when two sides are positive. No, you can square when both sides are negative. What you have to remember is that you need to change the inequation sign. Now you may still think that if one side is negative and other side is positive, then can't we square on that time? Do you really think that you will have to square? A negative quantity less than a positive quantity is a true statement. So obviously we will not make any further operation. If you have positive quantity less than a negative quantity, it's a ridiculous statement. Again, you will not do anything. So one side negative and other side positive, no mathematical operation is required. Squaring is required only when both sides are positive or both sides are negative. What I meant that only for positive two sides, you need not change the sign. Both sides negative, you will have to change the sign. One more thing before we leave from here, you have to remember that we talked about just beginning of inequations. There are many students, those who think that inequation means inequality. These are two different things. Inequalities are not to be solved. They are eternal truth. Like how you have seen in previous classes, like sin square theta plus cos square theta equal to 1. It's an eternal truth. Whatever value of theta you take, sin square theta plus cos square theta would always be equal to 1. I hope you all are understanding that they are called identities. Like how we have in case of equations identities, same way inequalities are certain truth. They are not to be solved. They have their certain proofs. So inequations are to be solved. So mind you please, here onwards, whenever you are solving inequations and not inequalities. I think for this session, these 4-5 rules, what we have understood, you try to revise them before we meet next time. Till then, stay tuned. Thank you.